Good afternoon, all members here. Myself, Dr. Sachin Sharma from East Point Group of Institutions. I would like to welcome all participants, students, faculty fraternity to this interactive session. Uh, I would like to thank the management and the principal from the East Point Group of Institution for such a event they have asked us to organize. And this session is basically on birth of lean manufacturing. Now, this session we will stress on lean manufacturing. What are the parameters related to this? How entrepreneurs run their companies uh, by having this idea in their mind, that is concept of waste. What is the role of different Japanese companies, because they are quite good in this. So that we have different type of questionnaires on this in this session. First of all, I would like to invite uh, Shiva sir here, Dr. Shiva from East Point Group of Institutions. Sir, please.
Thank you, Dr. Sachin Sharma, and all our college fraternity students and the students from other colleges, faculties from other colleges joined us showing interest in this. Before I initiate the program, take the program forward, I would like some of my seniors to be introduced. Hello. Invited. And I would look for their. I rather feel that no, I should start the program after getting their grace and blessings. So I am waiting for the blessings from the principal of this institute, East Point College of Engineering, and HOD Mechanical for their arrival. I believe both of them are there. May I request Principal Sir to come and grace the occasion?
Yes, sir.
Hi, sir.
Sir, still it is 3 minutes to go live. It has not gone live. There is a counter there.
Yeah.
Sir,
I don't know.
Let the guest come online.
Acha, sir, how do we know now that how many people? We are not online now, I believe.
Sir,
how do we know that?
Sir, it is. No, sir, it's already we are live. We are live. Sorry.
We are live. We are live. So, dear participants, I mean, dear audience, Dr. Prakash is our architect, the leader, and the motivator for all of us. And he is the person bringing all the teaching, learning, developmental programs, and faculty development, student development, industry, institute, integrated learning, attaching in industries with our campus and all the things. A lot of things are happening. We are now starting getting the tangible outcome from that. Now we are also planning to strengthen our PG programs, MTech programs, and like to streamline that, increase the intake, streamline the what you call their teaching, learning, and their career from their campus and their career and all the things. So I request our principal sir to grace this occasion. Sir, please.
Thank you, sir. Thank you so much. Thank you, IQAC and Department of Mechanical for hosting this program. Thank you, sir, for kind. Once again, I thank the guest for taking his time and effort to come over and spend the time with my students over here. Sir, thank you once again. Thank you, Professor, once again. Very kind of you. I don't want, we are already on live. I request Shiva to go with the Jayarajan sir and start the session immediately.
Thank you, Principal Sir, Prakash Sir. You are always our light and leadership. And even though he put only words in brief, it matters most to us. Now, before I hand it over, invite the speaker of the event, I invite our dear HOD Sir, Harishanand Sir, to what you call highlight the importance and gracious all. Sir Harishanand Sir.
Sir, thank you so much for this great opportunity, and we have to be thankful to the IQSC department of APCET for collectively hosting this program and jointly hosting this program. And I am so thrilled. In fact, we know that Shiva sir will, whatever it is, to any extent, if it is a subject of matter which is essential to reach out to the student, doesn't matter, he will ensure that it happens. So in the same line of thinking, this exclusive program, in fact, he hid in fact something I was asking about. Even sir, can I know the speaker also? He said he's one of the great personality and having worked at different capacities at different levels and at different places. So I'm very happy to see you, sir. I, on behalf of the department, as a part of the host of this program, I welcome Jayarajan Raman sir. And as Professor was indicating, the complete transformation what we are seeing in our professional career is to while working under Prakash sir, Dr. Prakash, the principal of EPCET, who have always been a very strong backbone of every event, every smallest program to the biggest event that is happening in the campus. And I don't know how to thank him, but for this occasion also, he is with us, despite he speaks about a minimum of 8 to 10 hours with students and different authorities and I don't know what not with the management and to the university. Despite all his schedules, he is with us here, sir. On behalf of the department and IQS also as a part of it, I welcome you, sir. And nothing much to speak about this one. Lean manufacturing is one of the key areas, not essentially only to the mechanical engineers, basically to the all technical schools students required to learn this process because it is connected to the manufacturing. So manufacturing, without the manufacturing, nothing can happen, nothing can go to the market. And when this lean is adapted in every system of production unit, I think there is a lot of outcome that has come. Basically, what I little know about this one is only initially it was called as a Toyota method of manufacturing since it was implemented, and later on it is spread and adopted by most of the companies, and especially although it started in Japan. And of course, our speaker, sir, today will be highlighting and giving us a vast knowledge about the subject. I don't speak much, but still, it is what I wanted to underline in this point of time is that certainly this is a subject which every branch of technical school student should have logged in and then learned. Just to spread this knowledge only, this today's event is scheduled. And I would really like to thank the Professor Shiva sir for organizing and being in contact with you. I welcome Shiva sir also, and I welcome each and every participants today and from different organizations and from our own organizations. And I'm sure that they are going to get benefited from today's event and this session. So it's over to you, sir. More because the more time I take, the students and the aspirants will get less. So I think it is time for me to hand over the platform to you. Thank you. It's over to you, sir. Thank you. Thank you for including me. I wish this program will be a great success. Thank you.
Thank you for your great words. Over to Dr. Sachin. Dr. Sachin is the coordinator of he is coordinating the program. Over
Good
to
afternoon,
Dr.
sir.
Sachin.
Good afternoon, sir. It's my pleasure to invite Principal Sir here and Dr. Harishanan Sir here on the session. Now, I would like to give a brief introduction about Jayarajan Sir, who is our speaker today. Sir has got, I was really, such a vast experience in the field of lean manufacturing. Sir has a very core competencies in design and development. Sir has worked in automobile sector for such a long period. He has worked in manufacturing and industrial engineering units. During his tenure, he has visited many countries like Germany, Japan, Russia, Czech, and worked in different profiles in different countries. Sir is a mechanical engineering graduate with post graduation in MBA, and I was really happy to see such a kind of vast experience in the field of lean manufacturing. And I would like to welcome Sir on this in the session where we'll have an interactive kind of session with the faculties and students of MTech. And now I would like to ask Shiva Sir to take a session from here to start this interaction with the Jayarajan Sir. Shiva Sir.
Nice. Thank you, Dr. Sachin. In fact, he is our colleague. Before I initiate the discussion or interaction, or what do you call now, invite the speaker and put questions onto him, I would like to, in fact, the speaker is much more than what Sachin Sharma sir had described, because he's beyond words. He has visited many countries, like the countries like Japan, Germany, Malaysia, Singapore, Russia, all the countries where the quality matters, Korea, all the countries where quality matters. There he has visited, apart from his what he call working abroad, working India, working abroad. He has many visits over there. And what all the things we are going to deliver today as accrued from his personal observations and experimentations, and nothing from the books. That is one speciality of this particular what you call interaction. Now, before let the what you call, we have comfortable 2 hours. Now let the chief guest, the speaker of the day, sit comfortable, settle comfortable, and let me put 2-3 questions to my audience. Like what is that? What is the stuff universities does not teach you? This thing I want a clarification from your side. What is the stuff the university does not teach you? This is over to you. I want the students, all the participants interact. This is not a classroom. This is not a what you call our normal Zoom section or our Google Meet or something like that. This, we are mimicking an interaction here. This, I want all the participants really involved in it. If you have understood the question, or you have accepted the question, you please put yes. All of you, all of the participants, please. I am requesting you, please put yes, why in the chat box. Please use the chat box and let me see the chat box, the response coming from the audience. But you call all the participants that you have got the question from me, that what is the stuff that the current university does not teach you. Any response? I am not finding any response from. If you have got the question, please text Y, letter Y. Yes, I got you. Please do that. Any response? Any response from the participants? Hello? Are we getting a response from the participants? I'm not finding any response. I want, yes. No, you don't have to put all the things. Yes, you just put the letter Y. Means, yes, you have understood the question. Please text, please post letter Y.
Shiva sir, Shiva sir, this is live on Facebook. What happens? The people will be sending the questions afterwards. No one is in the studio. It is not like Google Meet or Zoom. Okay, you can't see the immediate chat responses. Okay, so what I request is that you can just what are the questions that comes in, Rajneesh will try to post over here, and let Professor Jayarajan sir answer the questions. This is how the tool works.
Understood, but no, our Rajneesh sir would be able to understand how many response he gets. No,
no sir, I think it's again pooling concept is there, so you can just pull the questions for him. You can't poll the here.
I cannot involve the participants here, and I am first to this platform. I thought, okay, then I'll do one thing. I'll post the answer also here, that to become faster, cheaper, and better. I repeat, to become faster, cheaper, and better. That is not taught in the taught by any of the universities in the world. So I please post the answer. To become faster, cheaper, better. This is not seen in any of the university syllabus. That is the difference between university learning or a campus learning and industry learning. This thing you learn only from industry. University will not teach us to become faster. It will not teach you to become cheaper. I mean, produce things at less cost, and to produce things better. So these things will not be taught it. Please post that. This is a slogan I wanted to start with this slogan. I wanted to start this event. Faster, cheaper, better. Please post that. Please post my answer. The question I asked is, the stuff university does not teach you, and the replay I'm giving to you, my answer to is to become faster, cheaper, and better. Right. This is the thing which you will not learn from the colleges. Now you can take any example. You can take any engineering component, and you can prove this, that no, it is not, this concept is not taught at any of the universities. Now I wanted to put you another question. let the chief guest relax. There is two more questions. There are two more questions. Till the time, let the chief guest relax. Now, I wanted to ask you another thing. How the students get benefited by entry of MNCs or global enterprises into homeland? I repeat, how you or we get benefited by entry of MNCs and global enterprises into homeland? I think we all know about it. That answer I am giving, that no, our career become global. The students get no more opportunity to work abroad, and since we have more brands in the market, you can have choice on the product, choice on the purchase, then price competitiveness, quality competitiveness, and a lot of things you'll get it. Even economy of purchase, scale, everything is possible there. Now I put the third question. We purchase several items for our domestic use. For example, a sugar. How do you describe the purchase? How you decide the purchase of sugar quantity, frequency, sugar bin size? It saves storage at home. I repeat, we purchase many items for our domestic purpose. You take example of sugar. And how do you decide on the purchase of sugar quantity? What quantity you purchase? How do you decide? For 1 month, how many sugar you purchase? What frequency you purchase? And what size of the bin? What is the size of the sugar bin you use to keep it? And how do you store it? How do you manage the safe storage of the sugar at home? Have you ever thought about it? I think even though we all do this, and we unknowingly, unintentionally, or unknowingly do this, what you call purchase and store, use all these commodities, but no, we never have thought about it. We never have thought on an engineering lining. Probably today's discussion might invite, enlighten you to be more to be a more engineer in this regard. Now, coming to the next one, when we speak about quality assurance and lean manufacturing, which name of the country comes first pop up in your mind? I repeat, when we talk about quality assurance and lean manufacturing, which country's name pop up first in your mind? Can somebody give the answer in the chat box?
Shiva sir. Shiva sir.
Yes.
Shiva sir.
I'm
yes,
able to listen.
Yes, sir. 1 second, sir. Sir, one question. Let you tell and let Jayarajan sir answer, sir.
It comes to him. Next question onwards. From this question onwards, he'll take it up.
No. What happens? No.
Yeah.
I think that is easy for the Rajnish to post that question online. Okay. Because we are live on Facebook.
That is easy on admin. It's easy for admin.
Please let Jayarajan sir answer one question by one question. Don't take multiple questions at one time. So one question you give it, let him answer. Again, let you put second question. If you question 3 questions, probably it will be very, very confusing. Please, sir. Let first question be answered by Jayarajan. Over to Jayarajan, sir. Please, sir.
Okay. First of all, am I audible to everybody?
Yes, sir. Yes, sir. You are audible.
Yeah. So I would like to thank East Point College for giving this opportunity, and thanks to the principal, Dr. Prakash, and HOD, Dr. Hari Prasad, and Dr. Shiva and Dr. Sachin. Okay, let me take the question what Dr. Shiva put forward to me. The first question is, what the stuff the university does not teach you? That is a question Dr. Shiva asked. What I would like to answer for this question is, there are so many learnings happening in the industry every year. The development happening in the industry is very, very fast. Our academic syllabus is not growing in the same level of what industry is happening. This is what I wanted to answer that question. So whatever happening in the industries, there are so many management formulas, there are so many processes, and there are so many techniques, so many engineering happening every year. Every 5 years, there is a lot of changes in all this field. And these things are happening in the industries. That is not updated in our academic syllabus. So we are too theoretical in the college syllabus. At the same time, the practical things, what is happening is not getting updated to the students. But now things are slowly getting changed. This presentation and this session is something in that direction. People will help exposure. People will get exposure to such ideas when we discuss about these things with industry people, and if the presentations are with the people with the who are working in the industries as well as working in the colleges. So this is what my answer to the first question. If you see that one, when we started, when we were doing the engineering, this computer was very rare to see. Even final year only we could see one computer in our college. But at the same time, now everybody has got a computer on your hand. If you see it parallelly in the industry, when we look at the industry at that time, we were seeing only conventional machines. Of course, there are CNC machines at that time also, we were seeing that, but the level of exposure to us was limited when we were studying. But from the conventional machine or the CNC machine, it has grown up to the level of Industry 4 now in industry. And there is one topic what we are discussing here is a lean technology. It is one of the small area which is already developed in the industry. So this is the answer I wanted to give for the first question. And Shiva, if you don't mind, can you repeat the second question what you asked?
I want to skip. Actually, the questions were not here. I want to skip the question. I'll come to the third question. Like, you know, when I'll give the question and answer, you give the reply for that. The further.
Okay.
That when we think about, when we talk about, when one talk about quality assurance, lean manufacturing, and all the thing, the first the first name pop up in our mind is Japan. Right, even in the schoolboy's mind, you know, when we talk about quality, what you call lean manufacturing and all the thing, Japan comes proper first in his mind. Now, what is your comment on that? What could be the reason for that? Maybe historical or please.
Okay, why when we talk about manufacturing, particularly lean manufacturing, why Japan is coming in the first? The simple answer is whatever Japanese do, normally they will do everything in a very simple form. If they started with the quality system. See, if you see the development, what we are seeing in the industry is actually all started with the quality systems. They were trying to improve the quality. For improving quality, what they were doing the first is check the part, inspect the part, qualify the part, and release the part which is only good. That is the one initially they were doing it. Later they find that that is not the right quality. Quality means whatever we are doing is there should not be any rejection. So how to avoid the rejection was the thought process they started, and the whole industry, the techniques, whatever we are going to discuss, is actually a result of that one. So it is quality is not lies with the quality department or the inspector or the instrument what we are using to inspect. It is actually a chain reaction. It is right from manufacturing, it's right from process, it is from design, and even the people who are involved, all the stakeholders in the process who are involved is directly contributing the quality of their product. So, what Japanese specialty is, they make all the systems very simple. The difference from the other countries, if you see that Western the techniques and technology, or either management or in the engineering technology, you will find most of the time you will see that it's my own perception. We lose simplicity in Western, but if you see the Japanese technology, whatever this, it will be very simple to understand at any level. So that is their culture. Japanese, whatever they do it for people to understand, not only the one level of people, to understand everybody. So whatever the quality systems they develop, it is right from the bottom in the industry. So the systems what Japanese developed can be adopted and can be learned by the people very easily, all level of people. That is the reason it become popular. That is one thing I am talking about, the easiness of the process. Second thing is the result of that one. When small things, thousands of small things will together become a very big result. So this result, Japanese already proved and they are enjoying. And the same, whoever is learning from there, also enjoying the result. So it become popular. Japanese companies, most of the companies, they have their own standards. Toyota is having their own standards. Toyota standards are there. They follow the KANBAN system, JIT system, and lean manufacturing system. Similar way, Nissan is having their own system. What is that? The name of the system is, I don't remember the system, but Nissan is also having the quality system separate. Similar way, all the systems is break down to a simple form, and it can be referred by an operator in the shop floor and can easily be reproduced. That is the reason Japan quality systems are more popular. I think this answers your question.
Wonderful, sir. It is interesting that you put in it very nicely. Japanese are more natural in what you call in their production, and simple in nature. And they, when US US try to beat the cost with the mass production. I mean, our Japanese try to beat the cost by cutting so many other things like inventory, all the things. So thank you, sir. Next question, I wanted to really take advantage of your experience that you have touched upon NASA, Nissan, Boeing, Toyota, Honda, FMEA, quality, philosophy, so many things you have touched. So could you explain particularly the concept of product design philosophy and product design team to the students, to our students? I mean, with regard to the companies which you interacted, you worked, because you are a person associated, closely related with the with the products like precision products like aerospace components, automotive components. I mean, there's so many precision machining and even stampings and all, a lot of things you are involved in. So could you please explain our students the significance of the concept of product development philosophy and product development team with respect to this company's philosophy? How do they look upon? How do the Toyota look upon? How do Boeing, NASA, Nissan, and all look upon product development?
Okay. Product development is a very important team in industry. Whatever the product development team developed is only going into the production manufacturing team. So the efficiency of the product development is decide the efficiency of the manufacturing most of the time. This product development, it is not in one specific area. It is right from evolving the concept of the design and finding the market and release it for the design, and after design it's go for design for manufacturing, then look for the facilities required for that one, then product development, then design validation, verification, validation, then the manufacturing. All this process is a very critical, and it has to be seen with the importance at each and every point. Then only we can see a very good product in the manufacturing side. For this, actually, all the automobile companies are working for this one many years, and there are many standards involved. There are many techniques involved. The main thing what happened actually, so it started with, I can say it is with NASA. So NASA, you know that there is no error or mistake can be accepted, because it's only one chance. If you miss that one, you lose that. So how do you make a system, how you make any part, or how you make a mechanism without any error, without any mistake, without any problem, and it should sustain the way it is designed. So for that one, they have derived certain techniques. There are certain tools they have developed for their own purpose. And subsequently in automobile, it is in the beginning, there are three big companies. We call it as big Bs, three big Bs. They are Mercedes-Benz and General Motors and Ford. These three companies, these three giants, they have their own method of developing the product. And for each company, for developing the product, they developed a separate development system, so that there will not be any project delay, there will not be any problems in the development, there will not be any problem in the production, and there will not be any problem in the quality. For that, they have prepared the system. These three systems are independent system, but it is almost similar, but some is having more benefits, some less. Certain things are not available with the one company and other. But the supplier base for all these three, most of them are common. The OEMs, the car manufacturers, vehicle manufacturers, original equipment manufacturer OEMs, they have a supplier base who supply all the systems to them. This supplier base, sometimes it is common, and the supplier should meet the requirement of the OEMs. For that, these systems are transferred to the suppliers. So these three companies, initially Ford insists their own standard, then GM will insist for their suppliers to follow GM standards. Ford, then Mercedes-Benz will insist for their standards to follow the development. In that, it is technology as well as the management, both are involved in that. But later, the suppliers find difficulty in seeing this. Even if I am the supplier to all three, I have to follow three standards and three different systems. So it becomes sometimes a little difficult. So finally, the automobile FMVSS, the Federation of Motor Vehicle Society, and Automobile Society, they decided to have one common standard. So this common standard started with ISO 9001. It was first started. Then later, automobile company started with the APQP, that is the TS standard. So TS standard is only for automobile. IS standard 9001 is for any company, any industry, any organization. It can be, even colleges also use IS 9001. But TS standard, TS 16948, is the standard specifically written for automobile product development. And for Indian, it is called as IATF. Same number, it is 16948 only, but we call it as IATF. But internationally, it is called as TS standard. And this standard says that what are the procedures you have to follow to develop an product for automobile. That is, the headline for that one is APQP, Advanced Product Quality Plan. So this development plan shows all the procedures for the product, the foolproof method of developing the product for automobile. So explaining this APQP is a long process. I think that will subsequent question will get answered.
Thank you.
Yes, Shiva.
Thank you, sir. Now, in fact, it was a long question and rather a long answer. Now, to the advantage of the students, I mean, because we are all one way or the other way. First we learn the things for examination, then we learn things for industry. So to stress more on the first part, what do you recommend for the students to remember the typical management tools and quality techniques with respect to learning lean manufacturing now? Means I'm asking the typical manufacturing management tools and quality techniques. They should remember now, recall now with respect to learning lean manufacturing.
Okay, this is continuation of your the previous question. So in advanced product quality plan, the one of the important points I would like to touch. So otherwise, the discussion will be more fruitful if I touch that subject. So in that one, there is something called DFMEA, Design Failure Mode Analysis. So whatever you design, we have to do a failure mode analysis. Failure mode analysis should be done by a group of team. In the team, all the members should be present, not only the designers, all the people who are involved in the manufacturing should be present in the failure mode analysis, so that the problems at any level can be addressed in the beginning itself. The failure mode analysis, as I said, it was started with NASA, so that no failure will happen. They will take this mistake happen, how this design is addressed. If this is not meeting the strength, this will fail. So what we will do for that one? If the corrosion happened, what will happen? If the temperature is high, this will not withstand, though it will fail. For that failure, what we have to do? So each and every failure they will ask, and that failure will be addressed by the team in the design, so that all the failure will be addressed in that. This failure mode is a mathematical method, a scientific method of doing in that. So when we do the DFMEA, we have to do the what we call when we do the DFMEA, it is severity of the problem and occurrence of the problem and detection of this problem. This has to be addressed. This is the mathematical formula they used. So if the failure is severe, it's a safety problem, or if it is going to be fail the whole system, then severity will be very high. So this severity ranking is already given in the TS standard. As I said, in TS 16948, these standards are given. How the severity ranking can be given. Occurrence, this can occur how many times? Is it monthly, is it weekly, or it can occur when it runs some cycle? So that occurrence. And the detection, if the failure happened in the manufacturing, can I inspect that one and find? If you cannot inspect and find, it is very dangerous. But if you can inspect and find, then it is not that dangerous. Depends upon that, they will give the rating. And this ranking is also available in the standard. So we put the failure mode in different ranking, and these three parameters will be multiplied, and you get a particular number. If that number is exceed the limit, then that design cannot be accepted. So you have to redesign so that this number will come down. This is the failure mode analysis practice in the development process. So now come back to the question what Dr. Shiva asked about the lean. Lean manufacturing is actually one word I wanted to say is optimization of manufacturing. Process optimization is the one word for this lean manufacturing. So how you optimize the process in using the lean manufacturing technique. So there are various tools for that one. The baseline for that techniques. Different companies evolve different techniques, and some people they make their own standards. So here there is a baseline for that. Okay, what is that you are going to do with this value engineering first? Okay, eliminate the waste. This is the terminology you use. Eliminates the waste in the sense time, money, in both way. Not only the waste in the material or the process, it is waste of time and waste of money and waste of material, everything. So any waste has to be avoided by optimizing the process. For that, what baseline they use is, there are 5 basic points. That is value. Anything you do, that process should have some value. If you are doing a process which is not having any value, should be removed. There is no value adding by doing that process. So why you should do that one? So when you do this lean manufacturing process, first thing what you have to do, that you have to make the complete detailed process flow study and find out, and you have to assign value to every process. Each process you should value. This process is having a value, so you have to consider. This process do not have value, so please don't consider that one. So that is the first step. Every process has to be valued. Second, this value stream. How you prioritize this value stream? What is that? Whether it is value is how much value? How do you prioritize? If the value is very less, okay, you can consider this. Which value is very high, you have to prioritize that. So you have to stream the value. That is the second tool. And third is the process flow. For doing value and value stream, you need a detailed micro level process flow. So that has to be done. That is the third tool. Fourth tool is actually pull. Pull in the sense, suppose it is a customer demand. Customer is asking something and you are meeting the requirement. So it is pull. So I want every 1 minute 1 car. This is the pull. So when you ask for 1 minute 1 car, then you have to streamline all the process according to that one. In that process, there should not be any non-value adding process also. This is the basic things you have to do it in manufacturing. And after that, the fifth one is perfection. When you do this exercise, that is what value and value stream, process flow, and the pull mechanisms, you have to do in perfect way, because you are declaring that this is no value activity. For that one, you should be perfect. What you are saying should be correct, otherwise you will have a problem. And whatever the activities you are doing in the line, a streamline process, every line, every point, it should be perfect. How do you make perfect is a different tool. So the 5 tools employed for lean manufacturing, it is value, value stream, process flow, pull, and perfection. These methods actually done through various techniques in various companies. That's what we call JIT system, pull system, KANBAN, KAIZEN, 5S. Some people use TQM technology, 7 QC tools, AD analysis, ISOTS, whatever we discussed. All these quality systems can be used as a tool for lean manufacturing. And again, the bottom line, lean manufacturing is optimizing the process. that I think that I answered that question. If you want
Thank you,
more
sir.
explanation,
It was a long answer. We could have projected the same answer on the screen because students, it would have helped the students. But for the benefit of the students, I'll recollect that what Jayarajan sir was telling, summarizing. JIT, full system, Kanban, Kaizen, 5S, TQM, 7 tools, 8D analysis, and some of the standards he was mentioning about ISO, TS, I don't know, PQP, and all these things. These are all the things the students should remember when we when we initiate learning the lean manufacturing process. Now, coming back to the components like JIT, we call it JIT, just in time, then full system, Kanban system, KAIZEN, 5S, TQM, 7 QC tools, 8D analysis, international standards, ISO, QS, TS, APQB, etc. I would like to ask Jayarajan sir now. JIT mentioned was developed first in Kyoto plant in Japan. I repeat,
okay.
JIT, just-in-time method, was developed first in Kyoto plant, Japan. Now, what could have been the possible reason for this? Why this concept didn't got origin from any other international company, well-known companies like GE and Ford and all other NASA even. Why it got originated in Kyoto? What concept? What you have got to comment on the Kyoto production system? Is it linked with the Kyoto production system or TPS? Sir, please.
Okay, yeah, it is, as I said, JIT is actually optimize the process and the cost. Okay, why Toyota started this one is, I don't believe that it is started in Toyota. It may be in different area, but it was scientifically explained and taken as a tool for development is by Toyota. So now why Toyota has taken this one is in the competitive market. Toyota has to be sustained in the market. One is the quality and second is the cost. So quality, of course, there are so many companies are producing quality products. So how you compete with the other competitors? So one is your quality and another competition is the cost. So if you are able to deliver the same quality of the product with a lesser price, definitely your market is going to be higher than the other person. So that is one second reason. And third reason is the delivery. So you make the car for today's technology today, and people are able to enjoy that car in the same period, then you will get that market. So if you are able to deliver, suppose 1,000 cars are required every day, and if you are not able to produce 1,000 cars, you are losing that market every day. And this cannot be recovered after 1 year. Oh, anyway, I will make 1,000 tomorrow. It is not possible because there are so many competitors, and customers will not wait for your vehicle till you complete the process, because there are alternatives. If you are monopoly, that will work, but in a competitive market it cannot. So Toyota is entered in a competitive market, and they have to be in master in quality, they have to be master in cost, and they have to master in delivery. So for these three, they have used this just in time principle. So just in time principle, first, when you go for just in time, what it means is it is just in time. What is required, you get at that time. So that is just in time. Why it is? If you are, for your comfort, if you are keeping the part for a long time, if you are adding the inventory cost is going to be very high. So that cost will come to the product and the customer has to pay for it. But if you are able to reduce inventory cost to zero, that much cost will be reduced from the product. The inventory carrying cost is very high if you consider automobile product, because there are so many high value items which has to be stored for your to meet your manufacturing process. So if you keep the high value item for many days, then the interest of those items will go up and this inventory carrying cost will be very high, and this will come to the product. So Toyota wanted to make the cost of the vehicle less by doing this technology or avoiding the inventory cost. So that is the reason that it was introduced in Toyota. So first thing is the quality, because all non-value items they remove. Second one is the cost, the price will reduce. And third thing is they can deliver the part as they planned. And these three things they can meet with using this tool, that is just in time, so that all the suppliers will be developed to meet this requirement, and the manufacturing plant in the Toyota company also will be developed according to that. Suppose your plan is 1 minute, one car, everything will be streamlined for 1 minute, one car. But you, in this process, everything you cannot make in 1 minute. So that is a different process. But in the process line, you should take only 1 minute to assemble. The engine, that also parallelly you have to do it separate plant, make that one, engine should come into the line, and there is 1 minute only required to assemble that engine into the vehicle. But engine assembly is done in a separate place. But that engine assembly, every process is done in 1 minute. So you are disintegrating, or you are actually distributing the work to different level, and so that every process is in 1 minute and your line will be fulfilled for meeting the requirement, that is 1 minute, one car. So JIT is one of the tool they used for meeting this requirement.
Thank you, sir. Thank you.
Yes,
In fact, to reinforce a student learning, that is the purpose of today's what you call this interactive session. In fact, what was told that Ford, I mean GE defeated Ford, and Ford was defeated by GE, and GE was defeated by Toyota, and that sequence it was. So I just wanted to know whether the Toyota nurtured this tool to defeat GE. Is that in your one word answer, yes or no, something like that? The students get a motivation that this tool was developed to defeat. I mean, this tool was nurtured by Toyota to defeat what you call G. Was it like that?
It's very subjective. Okay, in the competitive environment, people use different techniques. So this is one of the techniques used the Toyota to compete, not only optimize their own process and compete with the other competitors. But this is not the end of the development. The Toyota, every year they do some kind of changes in this kind of process. After JIT, they have gone for synchronized delivery. Synchronized delivery is actually not even 1 minute. So everything is synchronized. So everything synchronized in the sense, yeah, it is called synchronized delivery. This synchronized delivery, some extent they have tried to do in Bangalore plant also. I have seen a successful synchronized delivery plant, which was a Mitsubishi developed in Malaysia. I got an opportunity to work in Malaysia at that time. I was supporting this company also. This Mitsubishi plant, they have developed a synchronized delivery to meet their takt time. As I said, engine, door, everything will be in a different place. Finally, it will meet one place and assemble. And the part will coming to the assembly line direct. It will not go to the stores. There is no storing the material. The products, systems, whatever it is to get assembled will be directly going to the line. And the line is designed such a way that truck can go to the line. And the part will be assembled directly to the car. So this is synchronized delivery. So Toyota is developed JIT, synchronized delivery also they tried. Many techniques they tried, but it is not probably competing is another term defeat. So you can say that you can defeat. They have done that. You can say like that.
You're afraid. You are afraid to blame the people. Okay, fine. Now coming back to the topic, we wanted to learn from you whether the JIT, just-in-time concept, is it company specific? Could we apply this thing to an engineering enterprise, or could it be applied to running a restaurant? How do they eliminate waste and save time there? Could you explain that to the students?
Yeah, this JIT can be applied to anywhere. But if you consider automobile itself, all the companies, it cannot be same because it depends upon the customer requirement, or I can say production volume. How many products are required? So based on only your back working this is based on that. Suppose you are making only one car, like a Lamborghini with a luxury vehicle. There, this principle will not work. There is a technology is different. Their intention is different. Here is a mass production. Then what you are doing is actually the car manufacturer at the minimum time. How can you deliver a quality product on time? This is what they are trying. Now, the Toyota just-in-time may not match with Suzuki. Suzuki time may not match with Mahindra. Depends upon the final product and depends upon the volume requirement, depends upon your manufacturing facility. If I don't have a facility to assemble the vehicle, there is no problem. There is no meaning bringing everything in. It has to be synchronized. So now Mahindra, if you see, they have a line of 150 vehicles. Mahindra Nasik line, it is actually cater for 150 vehicles per day. Maximum it can go 175. This is what they do it. But at the same time, if you take Suzuki, they can make 700 cars per shift. So how do they make? They have two lines, 1 minute takt time or 2 minutes takt time. What is the volume they require? And based on that, this assembly line will be designed and developed. So Mahindra developed a conveyor line for 150 vehicles. Suzuki developed a conveyor line for 700 vehicles per day. Okay, now you are trying to compare whether the JIT can be same or not. The moment you say that 1 minute, one car, here JIT application will be very, it will be very useful for them, because at any time what you are delivering is drawn at the same time. But if it is 150 vehicles, you need only 150 vehicle items one day. So every day you deliver 150 items, that also cost add, because suppliers will be in all over India and the manufacturing plant is in Nasik. So you ask only one day item, and every day the trucks are going to Nasik. That transportation cost and inventory cost all will be very high. So Mahindra, what will do appropriately, they will change the JIT method. They will say, I don't want everyday delivery for this suppliers. Whoever is in the Nasik and costly item, I will accept everyday delivery. But whoever is supplier from Bangalore or in Faridabad or in Bombay, those people will be supplied in a week basis or in a 5 days basis. There will be a KANBAN system, or there will be a plan according to that. So the JIT, the method they follow will be little different from customer to customer. It is based on the final requirement. And now come to the your question. You are asking, this one can be used to restaurant or not? It can be used anywhere. But finally, what is that you wanted to meet the customer requirement? You take the case of customer requirement in the restaurant. You cannot ask customer in a restaurant to wait for a long time to get his food. Okay, you cannot order tomato after getting order from a customer in a restaurant. So you have to store some item, then only you can immediately deliver to that person. Suppose if you wanted to make masala dosa, you have to keep rice. You cannot run rice, then you can make. There are certain process. Okay, so you have to grind that one, then you have to go for the curing. After that one only you will make dosa. So you have to prepare and keep it ready for JIT. So that way you can apply JIT in restaurant also, but depends upon the process and their end requirement. The style of working will be different, but principle of JIT will be remain same for all everywhere.
Thank you, sir.
Yeah, see, you have one more. You have actually put this one more things you in the beginning you said, then principle actually came in between, and that's a you say sugar. How do you find how much sugar is required by your homemaker? This is the question you put.
I was not very conversant with this system, like the platform today. And I just wanted to make the students participate in the program. Like, have you ever thought that how do they buy, how do they decide the quantity, how do they store it, and all the thing, and they may not have been. Anyway,
I got the message, but yeah, this
I think
for this question there is a.
We have already used our 1 hour. 1 hour is already used.
Please.
We have only 30 more minutes.
Yeah.
I think we'll go to some other lighter question. We'll go to some other lighter. No, we chance to hear the word line. Toyota decide their line. I mean, Mahindra decide their line. Ford decide their line. Designed their line and all the things. And I am, as a teacher, I am also very concerned about the students' knowledge about line balancing. What is line in industry? What is line balancing? So could you just, in a brief way, could you give them some insight into line balancing and waste elimination happening in in this background? Sir, please.
Yeah, it's a good question. Yeah, good question. Line balancing is very important for this lean manufacturing and any optimization of process. So line balancing, I indirectly answered in the previous question. Suppose you wanted to make a car in 1 minute, one car, your assembly line should be capable to do that. So how do we make that? You have to split down every process so that one stage, 1 minute is enough to complete. Like that, you have to bring down, split the process so that one station, one person is working there means it should be able to complete in 1 minute. So whatever the process inside, they will split so that every station can be crossed in 1 minute. Suppose the process is difficult, how do you manage? Instead of one operator, you put two operator. Suppose on one machine is take 1 minute, so you cannot do it. There are two processes there. Then you have to put two machines there. So this machine is taking 1 minute, 10 seconds, so I cannot match. Then that machine has to be replaced with a new technology, so that within 1 minute you can complete. So they will develop their own mission for that one to balance the line. One is you can split the process. When you split the process, you can split in such a way that 1 minute one process can be completed. In that one, you can add operator, multiple operator can be worked, or multiple mission can come, or one mission. There's space constraint come, you cannot put multiple mission. So same mission, faster mission with a different concept, different idea, they will put that mission. If nothing is not available, means they will go for a special mission design so that the balancing can be done. And many things you can do it in the line, particularly the robo, they will put for welding and riveting and all robo, so that many things will be done in a minute faster way, so that line will be balanced.
Thank you, thank you,
So,
thank you, sir.
yeah.
Now, I think we have to make the story, long story short, because we have covered what you call the first part of that, what you call the lean manufacturing, the element what you call just in time. Now, I wanted to summarize what Jayarajan was telling, explaining to us that no, just in time it's a philosophy. It's a time-saving philosophy, making the thing available at the the time you need it. And that's more of a philosophy, more of a principle, and all the thing. Now we need to implement it. We have to implement it. So when we talk about implementation, then we need to borrow the concept of KANBAN. So I would like to take you to the KANBAN system now. So the first doubt we have over KANBAN is KANBAN a better tool than JIT? Or can we eliminate the negative side or the demerits JIT carried in the industry? Sir, please.
No, JIT, it's a good principle and it's theoretical. KANBAN is a practical JIT. You can say like that. So just in time may not be possible. Most of the time it's not possible for many things. For that one, they have compromised many area. That compromised area is the KANBAN system. Considering the supplier base, considering the geographical positions, climate, environment, considering all this one, it has to be employed in companies in different way. So example, if we have a strike or a transport problem or heavy rain, then your part cannot be transported. Now Ford is in Chennai. Bangalore is making some part for Ford. Bosch is making, and the truck is not able to go to Chennai. Then how do they meet? One day production loss means crores of rupees loss. So we cannot do such things. So when we do the and when we do the product development, there will be an understanding between the customer and the supplier. So they discuss in detail what is the KANBAN system they can follow. So they will say 1 week product, 1 week production can be sent in one lot. Otherwise, every alternative day you send in KANBAN. So it is depends upon customer requirement and customer demand, and the supplier is able to supply according to this one. And there will be a different plan. Festival season, this plan will change. They say KANBAN system every week has to be changed to every alternative days. So this agreement will be done during the development stage itself. It cannot be done overnight. It's a long process. The planning is a long process. When the product development time itself, we will anticipate all these problems. Accordingly, customer will see the contingency, and customer will ask supplier also to the contingency. In case failure happened, in case some happened, how you overcome the situation. Those things they will think about that one, and they will make the plan accordingly, so that such kind of situations they will not face any problem. So this is the way the KANBAN system was evolved. So again, it's, if you say in one word, it is an improved version of JIT, or it is a practical version of KANBAN. Practical version of JIT. KANBAN is a practical version of JIT for certain companies. This we can say.
Thank you, sir. Thank you. I request the students to really understand the concept of Kanban and JIT. I mean, probably in this short time, we will not be able to explain you in detail, but please take it as the core. These two are the core of what you call lean manufacturing. Now, coming back to the content, e-commerce, we are so much engrossed today with e-commerce, like Amazon, what Amazon does, what Flipkart does, and what is this digital marketing and all the thing. Now, is JIT and Kanban applicable or related to e-commerce also?
Principle, okay. Suppose certain things, it depends upon the product and the customer requirement. JIT is always, you can get maximum advantage if it is a continuous production. If the e-commerce is related to a chain type continuous production, then it is more applicable. But in e-commerce, it is not a continuous process as such. But here we can use this tool for reducing the waste of time, waste of cost, inventory cost, all these things. What is the minimum inventory you can keep? This can be designed and stored. Another thing is, certain things in e-commerce, probably tomorrow this JIT may be more useful than automobile industry in e-commerce. The reason is that the communication system and transport system is very efficient now, and it is daily changing. Now, if you take the social communication systems, internet of things, IoT, and cyber, what is that? CPS, cyber physical system. So all these things can be used for knowing the customer pulse and inform that one to the manufacturer immediate and deliver as early as possible. Actually the communication is, customer should order and e-commerce people should locate who can deliver that one. They have to manufacture, get that one, and give to the customer. But if you are able to do an e-commerce person, if I get order, I can send that one from manufacturing place itself direct to the person. Then that will be the ideal case. The optimized session will happen there. That is happening because now we have a communication system everywhere. Through internet, everybody is connected. Somebody is asking something, means immediately that message can go to the manufacturer. Manufacturer can immediately deliver that one to the customer direct, and information can be exchanged through internet. So e-commerce also will be using extensively this one in future. Now they have limitations because inventory, if you don't have inventory, customer problem will be there. You have to deliver immediate. Sometimes if you are ordering laptop, that laptop, if it is a workstation, that may not be available. Your customer specification will be different. Based on that, you manufacturing it, then it will take time. There will be a lead time for that one. This lead time we can reduce if we are able to directly communicate with the customer, manufacturer, and deliver to the customer direct. So these are the optimization possible chances there in e-commerce. Means reducing the waste of time for delivery. Main thing what there is the communication. The communication gap can be reduced, and optimize the time for the delivery. This is possible in e-commerce.
Thank you, sir. I think we have left another 15 more minutes for discussion, and the rest of the during the last half an hour, we would try to answer all the students, questions we received from the students. So I
Okay.
think we will use another 15 minutes for our discussion to continue our discussion, and students' questions may be taken up during the last half an hour during the question answer session. We'll address all the students' questions now. Making the big story short now, mm, could you now explain the students what are the most suitable, what you call most suited, best suited companies for applying these concepts? What type of companies are most suitable? And our students would get a lot of university questions like, what is Kanban? How Kanban is relevant to what you
Okay.
call
Yeah.
lean manufacturing, and a lot of things. How Kanban can be practically implemented. Take an example of, say, one company, say casting, or sheet metal, or a restaurant, or hardware manufacturing, and then explain how Kanban can be implemented there. These are the type of the questions students can expect in the university. Now, to support that, could you now explain, if not explain, at least mention the type and the nature of the companies which are more suited for this techniques?
This method is suitable for the industries where continuous productions are there. More suitable where continuous productions are there. So there you can optimize the process. Every day the process is different. Every day product is different, means there the method will be different. So these kind of tools we can apply where the products are produced continuously, so that the process is streamlined and optimize the process and take the advantage of the repetition, and so that the process the product will be completed the minimum possible time. So which industry you ask, the answer is a continuous production company like automobile industries, or any consumer products which is having continuous production. They can use JIT and the Kanban system. Um, there is no problem for that one. The is all depends upon the plan. Okay, now you take the case of automobile. There is um a projection. The forecast will be there every year. How many vehicles will be produced in the coming year? So this is the basic data available for doing all other people, right from supplier, every tier 2, tier 3 suppliers. So this data will be available. This many vehicles they are going to manufacture, and for this month, these are the volume, and this will be available. For automobile, this will be most of the time very accurate, because the trend is known. It depends upon the climate, depends upon the harvest, depends upon the economic situation. People give the forecast, this is going to be the next year this, so that will be most of the time is be very close to the exact figure when it happen. Similar way, consumable also, other products, so like washing machine, fridge, everything. Parallelly, that also will be low. So the market study will be related to certain inputs. So the when they do the market study, they will have a different the formulas. What will be the next year demand, and what way we will meet the demand. So that can be known to the manufacturer, so that they can deliver based on the customer pull. So what kind of industry, if you ask, we can say that one is a continuous production industries. So one example is automobile itself. Even Boeing also, even plane also, we can do the same method. Any products which is continuously produced can be used these techniques.
Thank you, sir.
Yeah.
Students, now you listened from You listen to Kanban techniques, just-in-time techniques. Now, there are a lot of other things which you should know as a student. I mean, before you enter into industry, you should know, like, what is a pull-push system, what is Gempa, what is Muda, what is 5S, what is Poka Yoka. There are a lot of things you should learn, but you can ask. Suppose you have some difficulty, you came across any difficulty in learning that, you can pose the question here. I am jumping over to another concept because I have to make the long story short now, that we have left with another 10 minutes or so. I wanted to clarify from Jayarajan sir that when we talk about lean manufacturing, indirectly we are hinting at adding value at every stage. Every stage add value. That is what lean manufacturing. Like, suppose you're a student studying in first year, and nobody will promote you. Universities should not promote you to the next semester unless some value is added to you. This apply in industry also. So we are talking about value addition in every stage. To move a product from one station to another station, one machine to another machine, it's a value addition. Unless value is added, you should not move it. So that is what it is. Now, in this regard, how could Sir Jayarajan, how could you relate value addition to lean manufacturing philosophy or lean manufacturing philosophy?
Okay, you have indirectly answered in the question itself. We answered half. See, in every manufacturing station, we have to do the value and value streaming. So, just to understand that one, we take the case of a small example: tightening M6 screw. Okay, just to understand, we'll take this example. Now, you need a screw, and you need the main housing part with the thread, and there is a screw, and there is a tool required for that, spanner. Okay. Now, first thing, you have to take the housing first. When you take that, how you evaluate that one? First action is you take the housing. When you take the housing, you have to stretch your hand and take the housing. You don't want to go back and take the part, or you go to the another box and search for it. That is non-value adding activity. So if you are looking for housing, it should be in front of you. So you just pull that housing, so it's the minimum time required, and you keep that one. When you tight that one, this housing will not be stable. So you have to put that one in a place where it will be arrested properly. That is called the fixture. So in a table, so first of all, you have to design a table such a way that our hand should be free access to do that process. Suppose if they are all activities in ground, it is not easy to do that one for a long time. And if it is a 1.5 or 2 meter height, you cannot always do that once. So actually comfortable height is actually in 800 mm, 900 mm height. This is industrial standard, less than 1 meter height. In that height, if you make the table, operator hand will be on the table, and the part should be just stretch your hand and take it, so that there is no value added activity, and keep that part on the holding place. When you keep the holding place on that one, you should not struggle to keep that one on that one. By naturally, it should go and lock that one. For that one, what is required, you have to make. When you keep that process, there should be a sufficient arrangement. By automatically, it should go and sit there, and you just clamp it. So now the things are in position to tight. So for that one, you may use some hole, so that 2 holes. In the 2 holes, the pin will be there. That if you put that one, it's okay. Otherwise, if you make a square pocket, this part will go and sit in the square pocket, so it will not move. There are hydraulic clamps, there are toggle clamps. There are so many things are available to clamp that one. you have to find out according to your takt time which is required. So you design that one. Now the housing is kept there, and there is no time based because you have made the fixture such a way that when you keep it set, it should go. And the part should not sit upside down or left or right. Orientation should be perfect. So orientation should be perfect in the sense, in the fixture, you have to make an arrangement by naturally the part should go in the right place only. It should not go other way and take again upside down or left, right. It should not be. Then it is a waste. For that, if you say your ATM card is having an arrow shape, if that arrow is not there, means you do upside down all these things. How you put that one? Because arrow is there, first entry itself you are right because there is an arrow. It shows that one you have to enter like this. If you take the case of electric plug, there are 3 pins. In that one, the top one will go inside as a neutral, and that will decide the other one, which is the positive and negative, and always go into the same. So like that, you have to. That is called poka-yoke. When you make some arrangement, when you use that one, it will not go wrong. This method is called poka-yoke. So you make a poka-yoke arrangement to fix that part. Now you are stretching your hand to take the screw, and screw also should be in the same place. Now we will take the screw and put on the this one. So if when you put the screw on the hole, it will not enter. You have to struggle that one to put into that one. Why? Because the hole size and the thread size is almost same. So you have to align that one, then only it will go. So for that, what it is simple technique. If you do not have chamfer, it will not easily go. So it is a simple thing. You add a chamfer so that it will go easily into that one. Suppose if this is a very critical process, it's some engine and the time has to reduce, you can even give a guide. Chamfer is a simple thing. You can give a guide hole so that it will go, the screw will go inside easily. So now screw you have taken and put into that one. These are the techniques where this lean technology is applied. That's a simple thing I am saying to understand that one. This chamfer, fixture, poka-yoke and all. Now you have taken the screw and put that one, and now you have to tie it with a spanner. You should have only the spanner which is you required for tightening that one. You should not have a packet of spanner again search for which one is required, and that also in at your table on a certain distance so that you can pick the tool easily. You cannot, you should not be in a position that you have to search for the tool, all these things. So you have to take the spanner on this position. And normally in the Japanese system, and so the spanner should be returned and kept it in the same place. You cannot just throw that one. It should be kept in the same place. You can see that spanner shape is drawn so that you should keep always there. Why? If you are always there means when during the process, you will take that, always your hand will go that position only and take, so that the minimum time only will take to take that spanner. And the spanner also left, right, which is the right direction. You take that one and put into this one and tight. After tightening that one, now you have the screw. Many times you have to rotate that. So what is that? If you are having regular spanner means it is difficult to rotate one by one. So what if you are having socket kind of spanner? You can just rotate that one. So socket kind of spanner is the right one. If you use the other one, you are adding a value, non-value adding item because time is consuming more. When the moment you put a socket kind of spanner, you are reducing that time. Socket spanner also, you have a hinge type and rotate, and manually you are doing. It takes long time to rotate and tight. You put that one in a pneumatic wrench and you just hang over the top of your table and pull that one and take to the nut and just do the tie. Within a second, this can be tightened in that place. So what is required? What is the time which is required? You need a pneumatic wrench, or is a spanner, or is a socket spanner, or a spanner which is can be adjustable spanner to any size. What is that you plan? Okay, so if you are looking for optimized process and what time you have to complete that process, accordingly you have to design the process. This process flow is important. So If you have to design the process flow with the T-type spanner only, then you have to design with that one. And that time is allowed. You can take 2 minutes to complete this one. That is a design process. But it is designed for 30 seconds means you have to design all the tooling and the arrangement on the working table so that the operator, without any problem, 30 seconds, he should be able to complete. So he will go for pneumatic one. Now, after tightening, what is the tightness you have given? By hand, I tight something, another person will tight. What is the torque you applied for that depends upon person what. And this torque, again, morning will be 1 force and afternoon will be 1 force. After lunch will be 1 force. It cannot be. So what is that? The torque applied for that one should be measured. If it is not okay, you have to reject that one. So for that, what a torque wrench is having with a torque measurement. Is a reading coming means, okay, you stop. That is one method. Another method, what? That torque wrench cannot give more than what is the torque required. It is set that one. So when you do that one, if you are going on doing that, it slip. So what is the maximum torque required is ensured with the tool. So these are all the okay, and what is that, idiot proofing, the error proof, all these people say that. So once you use the torque wrench with a slip, the torque maximum can be applied is set. So your screw tightened torque is designed and it is always same, consistent. It will not be loose, never. Because you have designed a process such a way that using that tool, your product is perfect. This is the way they do. Yeah.
Thank you, sir. Now, I think our time is, we are lapsed with our time. Now, I would like to borrow 3 minutes from the students' question answer Q&A session, because I just wanted to make him to answer one more important question, then we'll close it. So I am borrowing another 3 more minutes from you, from the Q&A session. Now, Jayarajan sir has linked the lean manufacturing even with Industry 4. That he was mentioning about cyber physical system, interacting with the cyber physical system, interacting with the machines, interacting with the working system, interacting with the production system, with the cyber physical space. So this is now slowly it is getting linked with industry, most modern concept of Industry 4 also. Now I want the students to understand, because he explained the way he has explained Poke, there are concepts like SMED, single minute exchange dies, then flexible manufacturing, cell manufacturing, value streaming. These are all very, very important. When you go to when you go for when you sit in a final interview round, these are all some of the things they mix with your HR interview, your personal when they interview your HR people interview. These are the because these are all management concept, value concept, value manufacturing, value addition, and error proofing. And these are all the things you should know. If at all you have some of the doubts, there's any doubt in this, you can post the question, text your questions in the in the chat. Now there was one word sir was using repeatedly, talk time. That is spelling is TAKT, T for what you call tiger, and A for the first letter, K for what you call kingdom, and T for tiger. Talk, it's called tag time. So I think I remember once before, this was a question asked by university. So students, if you have any doubt about talk time, or rather I would request Jayarajan sir to explain what is talk time with respect to production time, setting time, lead time, and waiting time. So students might get a a brief concept about the industry, what they talk about: talk time, production time, lead time, setting time, and waiting time, and all the things. Sir, could you explain them, taking 1 minute, we are taking their time. I have one more question to you.
Tag time. Yeah, tag time is actually very simple. You remember that I told 1 minute for one car. Tag time is nothing but the minimum time required to complete one product. One product is completing time is called tag time. If you are getting one car in 1 minute, the tag time is 1 minute. If it is coming in 5 minutes, tag time is 5 minutes. So if you are making a fridge and that fridge is taking 1 hour to produce one fridge, then tag time for fridge is 1 hour. So it is nothing but time required to complete one product. That is a tag time. And setting time, I already said how the fixture is set. So for the completing the process, the screw tightening is only the process, but there are so many processes before that. Means setting the part. That setting is actually called setting time. I have taken a simple exercise, but if you take the case of a car body, riveting or the welding on the body, how do you set the part is very important in 1 minute. So the setting time is very important, and setting techniques I already explained what all things they will consider. So the one is setting time, then is the process time. Once the part is set, then the process will start, and this process timing is the pure process time. And I explained again process how you can reduce by using different tools and different method. Even you can change the process itself for reducing the time. Sometimes you have to change the machine itself. So that is process time. So all this time is important for line balancing. This timing is already is linking with line balancing. So setting time and process time. Then waste of time is actually during this process. When you do that, any action which is taking time and there is no value adding, you are searching for this one. When you keep the part, your part is upside down or it is left to right. So these things are happening means that is waste of time. So you have to reduce all the time so that the operator is always engaged for using his time for the process only. And this is what I can say the waste of time.
Thank you.
And tag time is actually one. Yeah.
I think we'll cut it short now because we are reaching students' question answer time. Probably there may not be many questions, so that's the reason I was reaching their time. Now, what I believe from learning and listening to you, learning from you and listening to you, that what I'm made to understand that lean manufacturing philosophy is going to be, or lean manufacturing is going to be the tomorrow's manufacturing mantra. So probably students, suppose somebody wanted justification, like how do you justify that the lean manufacturing is going to be the tomorrow's manufacturing philosophy. If anyone has got any doubt, they can post it in the chat that the sir can answer. And I would like to close our interaction and initiate the students, take up the students' question, what you call question and Q&A session, with a happy closing note. I would like to, I would like the organizers to post what you call to project my happy closing note that become faster, cheaper, better. Please project faster, cheaper, better. This is what industry expect from the students. This is what we don't learn from campus. Please. Now over to Dr. Sachin. I think Sachin should come forward now. Hello. Or Giriraj sir, Rajni sir. Rajni sir. Acha, we'll take questions now. There are certain questions coming. Can somebody read it out?
Good evening, sir.
Good evening.
Can you read out the question so that the audience can understand? I mean, well, it will add to the
One
benefit
of the
of the
important.
other participants.
Why is not Indian?
Sir,
industries-
one of the question I am able to see from the students is how large a company should be to implement lean manufacturing.
How large the company?
Yeah,
How large a company should be to implement lean manufacturing.
Okay, size of production. Sir, please.
yeah. Lean manufacturing is not depend on the size of the industry. Again, the lean manufacturing is optimization of the process. So it can be in any company, in a small workshop also can be used the lean manufacturing.
I would like to take another question. Is that answered? The answer is that
Yes, sir.
it hardly depends upon the size and the production volume of the company. It's rather a process optimization and waste control. Whatever waste, there are 7 waste. There are 7 waste. So that control is that. Now let me take the question from one of our
There is
teachers.
one question.
Yeah, that why it's a beautiful golden concept. Why Indian companies hesitate to install it? In fact, that may be answered over to Jayarajan sir. Personally, I feel some of
Yeah,
the companies have already started.
I don't know the question what you are asking is the same. Saw the one good question. Why Indian industries are not competitive even after implementing JIT? This is the question I saw on the screen.
Yeah, please answer, sir.
Yeah. So it is not that we are not competitive. We are also competitive. All our car manufacturers are very competitive with the world car manufacturers, and our car prices are also very competitive. But you may be thinking about different way. There are some countries are little more ahead than Indians. The reason is that most of the things in developed countries, they have developed many technology because of their market. Indians started using car probably another 20-30 years. In my childhood, only ambassador car was there. So if car was not used, means car manufacturer is not having business. So no investment was made in India for manufacturing automobile industries. But the thing happened in other Western countries. All the industries were having sufficient demand, and they produced cars and made a lot of money, and they invested further for further development. And this development happened in Western countries very fast, even Japan also. But unfortunately, it is not happened in India because our market was different. We were not so used to drive the car. Now only most of the families started using the car. So if you compare now Indian engineers and outside engineers, they are far ahead because they are exposed to that kind of environment, manufacturing, and manufacturing technology, machines they used, automation they employed, all different. We are not up to that level because our market has not reached up to that level. So if you are able to produce many huge volume, and your market is always steady, then money can be saved, investment can be made, and technology can be improved. Unfortunately, we are little behind others. That is the reason we see that difference. Otherwise, we are competitive, and our car manufacturers are also producing the quality cars with competitive price.
Thank you. Can we see the next question? Can you broadcast the next question to the screen?
Yes, sir.
Now,
Sir,
just
one more
broadcast it, we
question.
will read it.
Is KAIZEN and KANBAN relevant today?
They are asking
What is
KANBAN,
KANBAN? Yeah.
KANBAN
Yeah.
and
So
KAIZEN.
No, Kaizen and Kanban is two different tools. Kaizen is a Japanese word. The meaning is small improvement. So Kaizen is the one tool used for quality system in the TQM. So they ask all the people who are part of manufacturing to give the suggestions, small improvements. So this small improvement will give a better result altogether. So that small improvement in Japanese terminology, it is called Kaizen. This was used everywhere. So as I said, in the workstation, small improvement, whether you have correct type of tool, you have correct height of table is clean or not, sizes of the tool, whatever you are using, the boxes are correct, the environment is safe or not, you are easily to access all the part. These are all small things. This was done through Kaizen. That is called Kaizen improvement. It is nothing but a small improvement. Word meaning is small improvement. It was used as a tool for TQM for improve the quality of the process. The other Kanban is we have explained in the beginning itself. Kanban is actually a result of JIT. JIT is the word meaning is just in time. It is a very theoretical term. Kanban is a very practical term. Suppose Toyota is manufacturing a car, 1,000 car in a week, and you want the Kanban system to be followed in a week delivery. So 1,000 car parts will be delivered at a time. So they will make a Kanban every week once. Or the production and what is the plan, production plan, accordingly the OEM will decide the Kanban plan. So they will say that once in a week or in a festival season, once in 2 days, like that they will prepare the Kanban plan. So Kanban is actually a improved version of JIT, a practical version of JIT. Toyota follow Kanban. What we are seeing in automobile the manufacturing is the Kanban system. So every suppliers will be giving as a bunch of part which is required for one-time production.
Thank you, sir. Can we take the next question?
How large a company should be a implement
This is
in
answered.
manufacturing? Yeah, yes,
This has been
yeah, it is answered already. Yeah, irrespective. It can be any company, small or big. Everywhere you can use this lean technology. Whether lean is applicable to manufacturing industry only, or it can be applicable for design industry. If yes, then yeah, it design also principle is same. We can use design center also lean. A person who is working continuously on a design center should be comfortable, and at the same time we should extract the maximum out of that person on the working hours. So in the design center also JIT can be employed by giving the correct environment for him, correct tool for him. If he is having a finite element analysis tool, he can do that finite element analysis on the computer itself and find out that all the failure this thing, and design can be optimized. If he does not have, means he has to give to another supplier who can do FEA. Or FEA is not possible, means you have to make a prototype and test it and find out. So now you see the time gap. If you do FEA and finalize the design, it can be done in 1 month. But if you make prototype and do, it will be 2 months, 3 months. But if you do with another supplier, again quotation, all these things, and again the approval from the management, then you get it done from outside and from a reliable supplier, and that time. So which one you will take? All depends upon your requirement and the customer demand. Based on that, you can plan. Now your question is, JIT can be applied for the design center also. It is possible. I am telling the sequence of operation, how it goes. So JIT can be employed for this also to avoid the time. Suppose FEA is continuously you wanted to use, and FEA software is affordable for you, then you can put an FEA software and do it yourself itself, so that like a spanner on your working table, you have FEA on your table. So as simple as it is. But FEI is very cost expensive software. If you pay ANSYS software, it will go 30 lakhs, 40 lakhs. But if you buy and if you don't use, it is again a waste. So that also will come in JIT. You buy something and you don't, and like it's a waste. So you have to use a JIT tool appropriately in design center also. There is no problem.
Thank you, sir. I think the answer was very awesome. Like, I mean, the very product, lean manufacturing covers everything, even the agriculture, engineering, medicine, everything, every industry. Now, since now he mentioned about design, the very product development, very engineering product development, design is a part of it. So if the lean manufacturing is applicable for the product development, definitely it is applicable to design center also. Can we take the look into the second, next session, next question? If anything is there before we close. Any more questions? Organizers, any more question?
Yeah, but in between, Shiva, I wanted to tell some 2 points. Use touch SMED, single minute exchange die. This again, a die changing setting is a very time consuming process. So Japanese developed this technology to reduce the time for changing the tool. This tool is not the small tool like spanner, it is like a cardboard making tool. It is required a very heavy ton crane to lift and put it on the 1,500 or 5,000 ton machines like that. So this huge tonnage machine and huge tools you have to lift and keep, and it takes half day for setting the tool. So reducing the time for setting is a major task for them. So they decided many technology to exchange the tool. That is, it is SMED is a theoretical term, but they reduce the time for setting by automation, putting some the different mechanisms so that the tool can be put it in the machine direct. So that is SMED. And then one more thing you said is cell manufacturing. Cell manufacturing is actually company in the company. So all of the company itself split into different company, and all the small product will be produced in the different companies inside the company. That is called cell manufacturing. We call it cells. Cell is actually a different company. It works as a different company. But they produce their product and they give to the others. Customers are within the factory itself. That is the cell manufacturing.
Thank you, sir. Before we hand it over, 6 o'clock, we will hand it over to the coordinator, and before that, he can take 1 or 2 questions. And I may not get time to make an apology that in the beginning I had some starting trouble because I am very new to this YouTube streaming channel. I was very comfortable with other conventional platforms like what do you call Zoom, what do you call that, WebEx, Google Meet, and all the things. So we had a problem in the beginning, and otherwise I enjoyed the session. Like before I hand it over to the coordinator, I probably will take 1 or 2 questions, if any. Any more questions, sir? Any questions?
No more questions, sir, I think.
No more questions. I think well understood by all. So thank you. God grace. We will.
Sir, I would like to take it from here, from Shiva sir. I think no more questions are there, and I would like to take this opportunity to thank Jayarajan sir. It was a very informative session for all of us. In fact, all of the faculties, students, UG students, PG students, all. It's a very informative session for all of us. I would like to take this opportunity to thank Jayarajan sir. I'm very pleased to take this opportunity to thank Principal Sir, East Point Management, HOD Mechanical Department, Dr. Harishanand sir. And we would like to have such kind of events from Jayarajan sir also on the East Point platform, so that this such kind of sessions, which is very informative for the students. So I would like to thank all faculty members who are in the session. Thank you all students for posting good questions. So thanks to all, sir. Thank you.
Thank you, Jayarajan sir. As a principal, I think it was a great session. I had another
Thanks,
one.
Dr. Prakash. Yeah. Thanks,
I had
Dr.
another.
Prakash.
Thank you, sir. I had another session, but still I cancelled when I was listening to you. I thought I should be here with you. It was very nice session, sir. Amazing. Many concepts.
Sir, I should thank you, my dear principal, sir. You corrected me because, I had some starting problem in the beginning. And you kindly jumped in and, corrected me. Thanks for your handhold. Thank you, sir. You are always there to hold our hands. And thank you, sir. Thank you.
Thank you, Jayarajan sir. Thank you so much.
Thank you, sir.
Thanks, sir.
Thank you, sir.
Thanks, sir.
Thank you.
Thanks.
You can move out of the line.